Floor and Ceiling Systems. Lesson 5, Precast and Semi-Monolithic Concrete Slabs. Precast and semi-monolithic reinforced concrete slab systems started to become widespread in the 1950s, contributing to more efficient and economical construction. By using elements from these systems, it is possible to construct slabs of any size, within certain size limits, and adapt it for a modular system. The slab systems do not require specific structural calculations and can be constructed without formwork. There is no need for individual installation of reinforcement, except for sections cast in situ where necessary. Precast reinforced concrete slab with filler blocks. In our example, we show a classic E-type beam slab with a wall spacing of 240 to 660 centimeters. The primary load-bearing structure for precast reinforced concrete slabs with filler blocks are precast reinforced concrete joists placed with a 60 centimeter axial spacing to bridge the span of the floor in one direction. Above a certain span, the beams need to be doubled, increasing the load-bearing capacity and reducing deflection. To achieve less deflection and fewer cracks, it is recommended to use a system with pre-stressed beams. Important: pre-stressed beams must not be cut, as this would release the tension and compromise their structural integrity. The minimum bearing length of the elements on the wall is 10 to 15 centimeters, depending on the type and span. The ring beam must have unique reinforcement, and shuttering realized in a way to raise the beams 5 centimeters above the wall surface. This way, the lower longitudinal bars of the ring beam can then be placed under the beams, allowing them to be fully embedded. Filler blocks, resting on the lower edges of the beams, fill the in-between spaces. These blocks are typically hollow lightweight elements made of concrete, ceramic or even cement-bonded wood fiber with a height of 19 centimeters, similar to the beam. The slab system is topped with a 5 centimeter monolithic reinforced concrete layer with mesh reinforcement. Concreting is carried out together with the ring beam and the monolithic sections, filling in the gaps between the beams and the hollow filler blocks. Semi-monolithic reinforced concrete slab with filler blocks. More modern versions of the precast reinforced concrete slabs have special joists, giving the monolithic parts more room to participate in load bearing. The type presented here is the Porotherm slab system, made in the same modular system as its own masonry elements, with a wall spacing of 225 to 700 centimeters. The joists are pre-stressed. The low-height base, 6.5 centimeters, consists of a reinforced concrete core and a ceramic shell underneath. From this, the stirrups project every 25 centimeters. The joists have an axial spacing of 45 or 60 centimeters, and the required bearing length is a minimum of 12 centimeters. The tops of the walls must be protected against moisture by insulating sheeting and laying the cement-based mortar under the joists. For the duration of the construction, the joists must be supported at intervals of 160 to 175 centimeters and should be removed after the monolithic slab has fully hardened after exactly 21 days. The filler blocks are also designed with a lower height, 10 or 17 centimeters, providing more space for the in-situ monolithic reinforced concrete layer. They should be placed so that the joists receive the load equally on both sides, in rows perpendicular to the joists. The top reinforcement of the slab is constructed on site, with the bars leading through the stirrups. The joists are tied with both its top and bottom bars into the ring beam. The bottom bar is located on the top of the base of the joist. Its length is 200 centimeters, diameter 10. The length of the top bar, diameter 10, is 1/6 of the span in the slab field, minimum 80 centimeters. It extends completely through the ring beam and is folded over the outer longitudinal bar. The slab also needs to be stiffened in the transverse direction, which can be achieved by installing a monolithic reinforced concrete crossbeam. This is a crossbeam the width of a filler block, which must be installed at least every 2 meters. In the line of the crossbeams, we use a filler block of 10 centimeters in height to provide space for beam reinforcement, minimum 4 pieces of Phi 8 and Phi 6 stirrups, and the monolithic concrete. A reinforcement mesh of 150 by 150 millimeter spacing and 6 millimeter diameter is placed to form the top concrete layer of the floor. The ring beam, cross beams, the monolithic reinforced concrete top layer, and the monolithic parts of the beams are poured all at once. Semi-monolithic lattice girder slabs. For the lattice girder slab solution, the proportion of the monolithic part is further increased. The large surface consists of a thin precast reinforced concrete panel of 5 to 8 centimeters thickness, interpreted as permanent formwork, over which 14 to 30 centimeters of monolithic reinforced concrete layer is poured in situ. These panels are not mass-produced, but unique prefabricated products, with a typical width of either 1.20 or 2.40 meters. If the reinforcement is custom calculated, it can span 10 to 12 meters of wall spacing. The main advantage of this system is that the slab does not require any formworks, and the elements can be quickly lifted in place by crane. The disadvantage is that the monolithic part requires a lot of reinforcement, and supporting scaffolding must be constructed. Precast reinforced concrete plank slabs. Precast reinforced concrete hollow core slab. Of all the precast slabs discussed so far, the largest span of up to 22 meters can be achieved with reinforced concrete hollow core slabs. They also require the least live labor. The larger span is associated with a very high structural height, from 20 centimeters to 50 centimeters, in addition to the typical width of 120 centimeters. As these are custom-made products, it is necessary to calculate reinforcement to ensure the necessary load-bearing capacity. Another advantage of reinforced concrete hollow core slabs is that they usually do not require any top monolithic reinforced concrete layer. The hollow cores are necessary to reduce dead load and are suitable for mechanical ducting. The elements already have a considerable weight, but for this reason, the ring beam has to be made in 2 stages, first for the bearing, and then for the part coplanar with a top of planks. During the concreting process, the concrete must be kept away from the cavities using plastic plugs. Tie bars must be placed between the planks, ensuring that they act together with the ring beam. Precast slab with aerated concrete floor panels. Aerated concrete panels are solid. There is no need to use hollow cores, as the density of aerated concrete is significantly lower than that of normal concrete. The typical width of the elements is around 60 centimeters, but the span is limited to only 6 meters compared to the reinforced concrete version. The thickness of the elements can vary from 12 centimeters to 36 centimeters, depending on the load. The planks are connected with tongue and groove, which makes it more difficult to lift the elements in place and fit them together. No special reinforcement is required. The planks contain all the necessary reinforcement, and in most cases, no top monolithic reinforced concrete layer is needed.